So today we begin in this session by looking at other methodologies that predated the methodology we will then study to understand some of their strengths and some of their weaknesses. So before I go into these topics, could I ask how many of you have used composite indicators like human poverty index or a particular asset index to measure poverty? How many of you have used fuzzy set methodologies? Fuzzy identification, fuzzy theory, okay? How many of you have used sort of factor analysis, principal component analysis, multiple correspondence to create aggregates? Okay, good. How many of you have used counting-based approaches like unmet basic needs or counting-based approaches in Europe? Okay. So there's a lot of experience, again, in the room in some of these techniques that I will discuss. And so feel free to supplement what I say, to share your experience, to disagree. So this lecture really draws on chapter 3 of the book and chapter 4. And these were very daunting chapters to write. What they do is they survey different ways of looking at multidimensional poverty that have been used over time and assessing them in terms of a few key criteria. One is whether and how they use ordinal data. A second is the extent to which they reflect the overlapping or joint distribution of deprivations. And a third is the extent to which they give policymakers clear signals on how to act to fight poverty. It's daunting, it was daunting to write, and it's daunting to present because many very bright economists, statisticians, social scientists have worked to develop these methodologies. And many of our friends have worked in them. And we have a lot of respect for what these techniques can do. And so while we will be finding some weaknesses in them, we also identify ongoing ways in which they are part of the solution and will be used to clarify analyses of multidimensional poverty over time. So one value added of this chapter is simply notation. Now, you may not wake up in the morning and stretch and say, I would like to think about notation. But notation is really important. The letters that you use, the matrices, how you name things. And what we found was that the literature on multidimensional poverty measurement had many different notations. And so there was not a common framework where you could bring all of the different methodologies and assess them, help them to speak to each other. So chapter 3 very much does that, and it was a work of art. It took a lot of doing to find enough letters in the alphabet to bring them into this common framework. The second is we're going to try to clarify to you, in a sense to teach you each of the methodologies in a very light way, so that you have a sense when somebody in your country comes to you and says, look, why aren't you using fuzzy set methodologies? Or why aren't you using dominance approaches? Then you have an idea of what's motivating their question. You can talk a little bit about their concerns, and you know where to read further if you'd like to think about it more or go in and do some research on that topic yourself. And in particular, we're going to look at the assumptions that underlie these methodologies and their choices. And we found that was very useful because many of the assumptions of these different methodologies were never made explicit in the write-up, particularly the assumptions about the data that are used. And then there will be one slide for each approach on their pros and cons, just discussing when we are going to measure poverty using ordinal data for policy purposes, what do these approaches bring? So our aim is that these chapters and that this lecture will enable you to make informed decisions about why you are using different methodologies, and will also sensitize you to the questions to ask. Many poverty data are cardinal. Not many, but some. So income is a cardinal variable where it can go from 0 to a billion. And you know the increment between it. You know the cardinal, it's cardinally meaningful, the difference between $30 and $1, or $300 million and $297 million, or different currencies. Another example of a cardinal variable is body mass index. Another example could be years of schooling. But now when we are using these variables to measure human poverty, first of all, we have to think whether a variable that seems cardinal is actually accurate. A body mass index can never take a value of 0. You would be dead. And so what is the floor? What's the lowest body mass index for human survival is one question. And then, of course, low body mass index goes with unhealthiness in human life, but so does high. So if your BMI is below 17 or below 18.5, then you're malnourished or severely malnourished. If the BMI is above 33, then you are obese. And so BMI is something where you could use it as a cardinal variable, but more is not necessarily better because you get into the range of being obese with health risks. So we have to think about the relationship between a cardinal variable and human well-being, even if the variable is cardinal. Another example is years of schooling. It could be 1, it could be 12, it could be 20 for a person with a PhD. But in terms of human welfare, it might be that 1 year of schooling is much more important. So the gap between 0 and 1 is much more important than the gap between 19 and 20 years of schooling. And so it may not be a linear scale. So these are some questions to ask. But for now, I'm going to take examples of these to be cardinal. But there are other kinds of data. So a classic ordinal variable would be, for example, grades of, I'm trying to think of the simplest one. Let's take a subjective variable, self-reported health. Would you say that your health is excellent, good, fair, poor, or very bad? Okay, so that's a 5-point scale. And we know the order of those answers. We know that excellent is the best and very bad is the worst. But if I asked you to put numbers on that scale, would it be 1, 2, 3, 4, 5? Would it be 1, 3, 7, 13, 25? What is the cardinal distance between very bad and poor? Or between poor and fair? Or between fair and good? Is it the same for everybody? Ordinal variables are variables that you can rank. Excellent, good, fair, poor, very bad. But you don't know the numeric distance between them in a fixed way. And there are very well-known mathematical operations that you can do with ordinal variables. For example, you can use the mean of an ordinal, the median of an ordinal variable. You cannot use the mean. And so in chapter 2, section 4, we go into the operations of these different variables. Many of the poverty data are either binary or ordered categorical. So if you think of water, your water comes from a stagnant pond. That's very bad. Your water comes from a river, an unprotected spring, an unprotected well. That's unsafe water. Your water comes from a protected well, from a tap, a public tap, but it doesn't come inside your house. That's safe but inconvenient. Your water is pure and it comes through a tap into your house. That's good. So in these categories, we are able to order them into ranks. Very bad is stagnant pond, unsafe, unprotected spring, unprotected well, safe, protected spring, protected well, rainwater. And then the top might be piped into the house. But again, we don't know the distance between them. So what we have observed is if you think of the variables that relate to poverty, water and sanitation, housing, what is your wall made of? What is your roof made of? How much worse is concrete than bamboo? These are things that are hard to put cardinal numbers around. If you think of assets, how many you own, if you don't have enough detail to price the assets, what do you do with them? If you think of employment, unsafe work, insecure work, some aspects of work that can't be monetized, how do you use them? So what we observe is that many of the variables related to poverty, in mathematical terms, are ordered categorical or ordinal data. And so the operations that you can do with them are very different than those that are cardinal. Hopefully that clarified. If you have any questions about this is an important point. So please feel free to ask, or I can bring some slides tomorrow to show you. Now you saw this yesterday, so I'm just going to remind you of the notation. But yesterday I presented this notation with reference to unidimensional poverty measurement. Now the same notation is presented for multidimensional poverty measurement. So Xij is the performance of person I in dimension J. There are n people and d dimensions. An achievement matrix summarizes the achievements of all n people in d dimensions. So for example, this would be the income, this would be the years of schooling completed, this would be the health status or the housing quality achievements of each person. And the people are in rows and the dimensions are in columns. So Anna in the first row, Bob in the second row, Chang in the third row. And so a row provides the achievement vector for each person in each dimension. That's the row going across. And the column going down would present the achievements of all people in a single dimension. Okay? So just to give an example, we could have 4 dimensions and 4 people: income, years of schooling, sanitation, and access to electricity. And this is just an example of their achievement matrix. We're going to be using this a lot. James Foster will use this matrix to present the AF methodology in the next session. So we've already said that the row vector is for the person and the column vector is for the dimension. And now moving towards multidimensional poverty measurement. These steps are very similar to what we saw for unidimensional measurement. First, we choose the space. Yesterday, we talked about the choice of income or consumption as the space in which to measure monetary poverty. Now, we're asking what is the space in which we will measure multidimensional poverty? Will it be capabilities, resources, access to services, human rights? What's the space in which you're going to select indicators and measure poverty? And then there are the same 2 steps in multidimensional poverty measurement that we saw in unidimensional poverty measurement, drawing on Sen 1976. So the first step is to identify who is poor, very clearly who in this room is poor. And the second is what? Cool, aggregation. So, given this framework, I'm now going to, for the rest of the time, discuss these 7 methodologies. Dashboards, composite indices, Venn diagrams, dominance, statistical approaches, which is PCA and factor analysis, multiple correspondent and latent variable analysis, fuzzy set theory, and axiomatic approaches. The first 2 of them use what we're going to call marginal methods to aggregate data, in that they look at each dimension in isolation. And the last 5 reflect what I'm going to call the joint distribution of deprivations, which is the row of each person. Their achievements in each of the dimensions. So each person has a bundle, and these last 5 methodologies consider the bundle of achievements that they have. So, method 1. The first method is, I think, the one that's very common from the Millennium Development Goals, which will be common in many of the Sustainable Development Goals. And it's to look at each indicator one by one. What percentage of children are malnourished? What percentage of children are out of school? What percentage of adults lack decent work? What percentage of women do not have equal pay for equal work? What percentage of children lack their rights protected? So in this kind of approach, there's a unidimensional poverty measure, but now the space is no longer income, but it could be all of these different spaces of education and health and child rights and gendered issues. So, bringing that into our notation, N is the population size covered by each dimension. In the case of a dashboard, we could be looking at different populations. I just mentioned all children being malnourished, or school-age children not in school, or women who lack equal pay for equal work. The number, the denominator of these dashboard indices will be different. We're going to have xj denote the vector which summarizes the achievements. So this is a column vector where each child or each woman or each person in the society has one entry. And xj is the vector. And zj or zj is the deprivation cutoff. What does it mean for a child to be malnourished? It's usually that their z-score is 2 standard deviations away from the mean of the reference population. What does it mean for a child to be out of school? It means that either their attendance or their enrollment is categorized as non-attending, non-enrolled. So you have to select the deprivation cutoff for each variable in a poverty dashboard. Again, we are talking here always about poverty. And then you have a unidimensional poverty function of this vector and this cutoff. So remember yesterday we had 4 people in a vector of monetary poverty. But now those 4 people will be children and their nutrition rates, or children and their school attendance rates, or adults and their access to decent work. So we're going to have a single vector for each indicator on the dashboard. And the dashboard is simply going to collect the different PJs, the different poverty measures for the different dimensions. Is that clear? So we're bringing this into a notation, getting you familiar with the notation. It's a very obvious, almost, I'm making it more complicated than it is in practice, but it's so that we're getting used to the terms that we're using. So this vector of different indices is a dashboard. And the word dashboard or control panel just means that you have different inputs into your decision making that are not linked, like the speed of your car, whether or not you have petrol, whether or not you need to shift gears or change oil, or look at your electrics. So the dashboard, just like looking at child mortality, child nutrition, gendered issues, that gives you different inputs into aspects of poverty in the society. I'll say right now that dashboards will always be used. So the rest of our careers, we will work with dashboards. So it's not a technique you can ever get away from. It will always come in and is very valuable. I had an example that Gisela had made from the global MPI of the dashboard of the 10 indicators of the global MPI. So that will appear in the slides that are online. So what are the advantages of the dashboard? This is very important. First of all, it is multidimensional. So the different elements may include health, education, nutrition, housing, violence, gendered issues, child issues, environmental issues. So they can include whatever dimensions are relevant. The second is also very important. They can bring together different data sources. You might have violence from administrative data or from a victimization survey. You might have employment from a labor force survey. You might have the child variables from a DHS or mixed survey. You might have gendered issues from a particular women's or working women's survey. And so a dashboard does not need all variables to be in the same survey. It also can use different data sources like administrative records, like big data, because there's no linkage between the different variables in the dashboard. They're independent completely. And the other advantage is that they can show information on different groups. You can have a youth employment measure for children, for young people ages 15 to 24. You can have an elderly measure. You can have a women of reproductive age measure, a child measure. And these are all different population groups, ethnicity groups, rural and urban groups. And these will have different base populations, different population sizes. But they can all be of interest for different purposes. So it's very flexible, we will always use it. But there are some disadvantages which are, in a sense, important to know when somebody in your country comes up and says, we already have measures of poverty in a dashboard. Why do we need an MPI? That's a very common question. What is the value added of an MPI? Why isn't the dashboard enough? And that's why you need to know some of the limitations of dashboards. So one is that there's a lack of hierarchy among the indicators. You might have 6, you might, as in the case of the Sustainable Development Goals, have 231 indicators. Which of them is most important? Are they all equal in importance? What is a policymaker to do? The relative weights of indicators in a dashboard are completely missing. There's no priorities. A second is that basically they're unwieldy. If you start to talk to the press and the media and they tell you has poverty gone up or down, and you start to list off all of the different aspects of poverty and how they've changed, the journalist will walk away in a daze. It's too much information for them. And so there's a value in having a single headline that captures a number of important deprivations and says, overall, multidimensional poverty went up, went down, or stayed the same. Otherwise, in a dashboard, you'll always find some things went up, some went down, some were the same, some didn't have new data that year. And so it's hard to get a clear message. And why do we need a clear message? It's not that we want to be popular with the media. It's that we really want to give policymakers information to act on and give civil society information to hold them to account. And so having clear messages helps us to do that. The hierarchies, I also covered trade-offs. You know, how important is malnutrition compared with perhaps how many rabbits one owns? You know, are they the same importance? A dashboard, again, lacks the weights between them. But there's another feature of a dashboard which is quite important, is that the dashboard never identifies who in the society is poor, because these are disjoint populations. So we don't have the percentage of poor people in the country from a dashboard. We simply have the percentage of children with this condition, or women with this condition, youth with that condition. But again, to allocate your budget, to monitor progress, you need more of a society-wide view. And identification is useful for that. And the final problem is that it looks at the deprivations one by one. And I'm going back to yesterday morning, where I said when poor people describe their situation, it's, in a sense, the clustering of deprivations. It's when they accumulate. It's when many things are striking you at the same time, many tiles from your roof are falling, that poverty is at its worst. So I'm a victim of violence, and my child is malnourished. I don't have a job, my roof is leaking, and my husband doesn't either have a job or good work. So it's the overlapping of deprivations which characterizes the worst poverty. But dashboards don't cover that. They simply look at things one at a time. The word I'm going to use for the overlap is joint distribution of deprivations, and it has to do with the row vector of each person. Okay, so the second methodology has to do with the creation of composite indices. And I want to clarify that we're using composite indices and distinguishing an MPI from them. So we are not calling an MPI a composite index. And that is because the MPI identifies who is poor separately and then aggregates information on poor people. So again, in a technical academic sense, the MPI is not a composite index. People often say, but you're adding up different dimensions. It looks like one to me. And so you choose your own vocabulary, but you'll notice that in the book or in our presentations, we distinguish MPI from composite indices. So the Stiglitz-Sen-Fitoussi Commission, for example, recognized the need to develop a single measure of quality of life. And so what happens is that you take this dashboard we just went through of different indicators, and you aggregate them into a composite index using some functional form. There's a whole literature on this. There's a fantastic research center in Italy, the Joint Research Center, which looks at a lot of the technical properties of composite indices. The Journal of Social Indicators Research, the Institute of Quality of Life Studies. There are many groups that really focus on trying to understand and improve the structure of composite indices. And I can tell you that some are much better than others, as being a person who analyzes them regularly. But let me give you an example of a composite index, which is the Human Poverty Index, which was produced by Amartya Sen and Sudhir Anand in 1997 for UNDP's Human Development Reports. And from 1997 until 2009, it was reported as the lead poverty indicator for UNDP until the global MPI replaced it in 2010. So it had a dashboard of 4 indicators. The first was the probability at birth of not surviving till your 40th birthday. The second was the percentage of adults who were illiterate. The third was the people who lack access to safe water, the percentage of people lacking access to safe water. And the fourth was the percentage of children who were underweight for age, so undernourished. So what they did was they used 3 dimensions of HDI, health, education, and income or living standards. For living standards, they simply took a simple average of the last 2 indicators. They added them up and divided by 2. So you're adding up the percentage of people lacking access to water and the percentage of kids who are malnourished. So if you have 10% of people lacking access to water and 20% of malnourished kids, what's your average? 10 and 20? 15. Yeah, okay. So that was living standards, and then health and education were simply the percentages. And then they took a general mean with the order 3. So they cubed each of the indices and then took the cube root. We can talk about why they used a general mean rather than an arithmetic mean, but they were trying to give incentives for countries to meet all 3 of these targets in a balanced way. And that was the Human Poverty Index. And its axiomatic properties are well spelled out by Anand and Sen in their background paper for the Human Development Report Office, which was published again in 2000. Let's say we have 2 distributions of 4 people and 4 dimensions. The people whose entry is D are deprived in income, education, shelter, and water. The people whose entry is ND are non-deprived. So what does a composite index do? It aggregates vertically for each of them. These are not the same 4 indicators as the HPI, but let's do that. So 25% of people are deprived in income, 25% of people are deprived in education, 25% in shelter, 25% in water. So you have a dashboard at the bottom, 4 numbers of 25%, and then the HPI aggregates across them with this general mean to create the human poverty index. Okay, so that would be 25% in this case. So that's what a composite does. The order of aggregation of a composite is column first and then across the rows. So first you go down each column and get their totals, and then you go across the rows. So if you look at the second distribution, going down each column, what percentage of people are deprived in each? 25%. So both matrices would give the exact same human poverty index. Just to fast forward, a joint deprivation approach aggregates first across the rows and then across the columns. So it would say person 1 has, in distribution 1, has how many deprivations out of 4? Person 2, 3, 4. And how about in the second distribution, person 1? Person 4? 4. Yeah. So the joint distribution approach aggregates first across the rows and then across the columns. So it would see a difference between these matrices that composite indices do not see. So one advantage of the composite measures, it gives an over-up view, the human poverty index. Most of the composite measures are not related strictly to poverty. So social progress index, human development index, legatum index, global peace index, ease of doing business index, the slavery index, physical quality of life index. All of these are composite indices that take a column first aggregation approach and then aggregate across the dashboard. They all give a single measure of different phenomenon, but very few focused on poverty. Just like a dashboard, it can combine different data sources. Just like a dashboard, it can combine information on children with adults. It can also normalize indices, so look at the minimum and the maximum of different populations. And it does, unlike a dashboard, because it aggregates, it has a hierarchy, it has weights, trade-offs, and makes these explicit. Okay, so those are advantages of a composite index. The disadvantage is that there is no identification of who is poor. So if you think about the HPI, who is poor? What percentage of people in my society are poor if my HPI is 0.25? We don't know. We don't know if the children come from the same households as the adults. We don't know if the adults should be considered poor if their children are malnourished. We have none of that information. So there's no identification. And then, as I already showed you with the distribution 1 and 2, it ignores the joint distributions because it's column first. So whether each person has 1 deprivation or 1 person has 4, those societies are identical for a composite measure. Is that clear? Again, we will all use composite measures, and I certainly myself have principles that I like them to fulfill. I'm not saying that they're in any way wrong, but there are some disadvantages. A third disadvantage is that sometimes they are difficult to interpret. The human poverty index perhaps less so, but some, for example, like a social progress index where there's various stages of normalization and aggregation, it's really quite difficult to understand how the raw data from different years and different surveys come into the overall index. So moving on, these were the first 2 methodologies, and they are the ones that disregard the joint distribution. And the last 5 methodologies take it into account. So first, just to review, this is our matrix of people and dimensions with a vector of poverty cutoffs, 1 per dimension. And as we already saw, the column first approach, we call it, they're looking at the marginal distribution. That's the vocabulary that we use. And so it's looking at each dimension in isolation. That was what the dashboard and the composite measures did. But the joint distribution now looks row first. So it looks across each person's profile and aggregates the number or the weighted sum of deprivations that they have. It creates an aggregate for each person. So each person gets their deprivation score, and then it aggregates across people. So any measure that reflects joint distribution has that feature. So let's start with the very most simple, which are Venn diagrams. This is a graphical way of presenting a crosstab. And we saw crosstabs yesterday when we were looking to see if indicators were the same. I could have used Venn diagrams when I was showing you the overlap between under 5 mortality and having an educated adult at home, or under 5 mortality and child malnutrition. So this is your crosstab, with N11 being people who are deprived in both indicators, N00 being deprived in none, and the others being deprived in one but not the other. And we take that crosstab and we move it into simple 2 circles. The people deprived in dimension 1, the people deprived in dimension 2, and the overlap is the people deprived in both. It's very simple. I'm just again going from notation to a diagram. And N00 is the people deprived in nothing on the outside. Now you think that this is too simple to be respectable, but Sir Tony Atkinson, for example, or the European EU 2020 poverty measure basically rely on Venn diagrams. So I showed you yesterday this picture, which is from the EU 2020, the European report, and you can get these for every country for every year. On the website they have these 3 circles for every country so that you can look at the overlaps between quasi-joblessness, relative income poverty, and material deprivation, an index, a composite index of material deprivation in Europe. Sorry, again, when you see the final slides, you will have a slide showing you the difficulty of viewing Venn diagrams with 5 dimensions or more. So 2 is fine, 3 is possible, but when you get more than that, it's quite difficult to read. So what are the advantages? First of all, in terms of communicating to your grandmother, Venn diagrams work, right? Grandma can understand. So they're very, very clear. And they do show the overlaps between indicators. So they're actually informationally very rich. And for 2, 3, even 4 dimensions, you can understand them. Beyond that, 4 is difficult, 5 is impossible. But there are some disadvantages. One is that it may not identify who is multidimensionally poor. So in Europe, they report people deprived in only 1, 2 or more, or 3 deprivations at the same time. So there are 3 numbers, but they don't necessarily nominate one, although the one that's favored is anybody deprived in at least 1 of those deprivations. There may or may not, therefore, be a summary measure, and that depends on how this information is used. Every dimension is converted into deprived or non-deprived, which is common to the MPI, common to many, but you may lose some information in doing that. Another difficulty of Venn diagrams is that they are all equally weighted. So if we had, our child malnutrition, adult illiteracy, and long fingernail example, they would be implicitly equal because we're looking at them and their overlaps without any weighting, without any preferences. So in a sense, they are used descriptively in Europe as an interim process, as a way of visualizing the data, which is very popular right now, data visualization. But we need work to convert them into a measure, to understand their axiomatic properties, to use them for policy, to disaggregate them. They, in the end, the way they are right now, they only present a headcount ratio, which cannot be broken down by dimensions. So the next is a return to dominance, now in a multidimensional space. So yesterday in the unidimensional poverty section, at the end I very briefly touched on dominance approaches. And this is a very powerful technology when it works. Often it doesn't work, but when it does, it's beautiful. So what dominance does is it ascertains whether poverty is clearly lower or higher in a distribution for all functional forms, for all poverty lines. Foster and Shorrocks and Atkinson specified many of the approaches for stochastic dominance in the late 80s. Bourguignon, Chakravarti, and then Duclos and Younger in the Economic Journal developed this into multidimensional space. And if you can say that it doesn't matter what poverty measure you come up with, poverty is lower in the South than in the North, that has a lot of political power, because then nobody can, come to you and say, but you should have used this poverty line, or you should have used a different functional form. We saw yesterday that the cumulative distribution function in unidimensional space is what we plot with standard errors, and we look at whether these cumulative CDFs overlap or not, in order to identify first order stochastic dominance. If we can't find first order dominance, we can look for second and third order dominance. Now we're going to think about this in multidimensional space, and so we have surfaces rather than curves. So bidimensional dominance is pictured there. It's hard to picture some of the higher orders. And we're going to see if these planes intersect with each other or if they are distinct. Okay? So there are a number of techniques of doing this, and as we will go on when we have the session on robustness tests, we do look for dominance within a restricted range. And we have published work on that, Maria Masantos and I, in our initial paper on the global MPI, looked into dominance for that. And the reason is that if you find dominance, it's a very strong empirical claim that you can make. And dominance, as I mentioned, for different dimensions following Duclos and Younger, does look at the joint distribution of deprivations. Usually it uses deprivation cutoffs and doesn't assess their dominance. And there is, in that literature, a feeling that it avoids decisions. You don't have to decide what poverty measure you're going to use. This is a literature for which I would have a friendly rebuttal to some of the claims. Because what happens if you find dominance? You can say that poverty in the South is lower than poverty in the North. But you can't not say how much lower it is. And let's say after 5 years you redo the survey and again you find dominance. So you can say poverty in the South is lower than in the North. But people want to know, has the distance between them increased? Is it the same? Is the North less poor relative to the South? You can make no cardinal comparisons between regions using dominance. You can only say more or less. It's on or off. And very often, particularly for following poverty over time, we want to know how much poorer it is, and has it changed? What has improved? What has not improved? Dominance also has no complete ordering. And the other key problem for dominance is sample size. So if you're going beyond, if you don't find first order dominance, and you're looking for second and third order, then the sample size increases that you require to do these exercises increases exponentially with the number of variables. And so Duclos, Son, and Younger managed 3 variables, but you could never do dominance for 10 variables. You would never have surveys that are big enough. And so there's a very strong limit in terms of the number of variables you can really explore using these strict techniques. And also, when you go beyond first order dominance, which many can understand, these planes don't intersect, then it's more difficult to capture the intuition of second and third order dominance. So it's something that we explore, that we look at, but for me it is insufficient, because I think knowing cardinally how much poorer this region is than that is important. And also, many times when you try to explore dominance, you don't find it. And so then that question is, what do you do when you don't find dominance? Then can you say nothing? Or can you implement a poverty measure and say something? Okay, so the next is something that it looked like a lot of you had used, which were statistical approaches. This assessment took us the most time of looking at all the methodologies, partly because it is the most widely implemented, partly because it is an area in which many of the assumptions that are made by analysts are not explicit. And that's partly because our computer programs, Stata, SPSS, hide within the commands a lot of assumptions. And so we wanted really to go and do some foundational research and understand what's going on when we use factor analysis. What are we assuming about data? What are we assuming? How do we use these different approaches? And of course, we use statistical approaches for different reasons. We could use them to identify who is poor. We could use them to aggregate information into an index like the DHS Wealth Index. We could use them to identify weights to apply to different variables. So there are many different uses that these statistical approaches have. And we actively use them anyway when we design measures, to understand relationships between variables and to set weights. So I think that this is quite straightforward. You will know this, but the statistical methods follow into model-based approaches, model-based methods, and descriptive methods. And your model-based methods are going to be your latent class analysis, the mimic models, factor analysis, structural equation modeling. And descriptives are the PCA, MCA, cluster approaches. So we'll describe them differently. So these are the sub-steps, and this is what I think is very important to understand. It's written at a high level of generality, but if you know one technique well, you can follow this through. So first of all, you begin with your achievement matrix, N people and D dimensions, and entries for each of the persons in each of the dimensions. And then what you're going to do is find some reduced set of combined achievements. So it might be your factors, how many factors you're going to save in a factor analysis. It might be your principal components. And what those do is it reduces D, all of the dimensions you started with, to what we're calling D with this little swingy hat, a subset of new factors, let's call them, that has fewer dimensions in it. And then very often, what you do is you may aggregate for each person those factors. You may combine them in some way. So each person gets a score which aggregates their factors, which aggregates their principal components. And so you get a vector of person-specific achievements. And that each of the entries, in a sense, represents an aggregation across all of the dimensions, but instead of doing it in a counting-based method, you've done it via these intervening components or factors or clusters. And then you may combine that vector into a scalar, into an overall summary measure, like a DHS wealth index. So that's the stages that we go through in different ways with these different methods. And what we found is that many of the decisions that you make in these stages are not explicit. Do you use the covariate matrix? Do you use the correlation matrix to start with? What do you use as your starting point? Which factors do you save? Which eigenvalues? How do you actually aggregate? And there are different ways of doing it. There are different options. If you go to theory, there are many different options. And you find that because Stata and SPS choose some or give priority, sometimes we think that they are right. And so we don't do robustness analysis. We don't even understand the choices we are making when we implement these techniques. There are also data considerations. Multiple correspondence analysis is appropriate for use with ordinal data, but strictly speaking, PCA and factor require cardinal data. And I think I'm getting ahead of myself. Yes. So first of all, what are the advantages? They do address multidimensionality. So they do take your original achievement matrix and bring it into a scalar. And they do consider each person's joint distribution. Each person gets a score reflecting their joint distribution. And certainly, confirmatory factor analysis can help strengthen how variables are located in dimensions. It can help us to understand in a complementary way to the association and redundancy tests we'll go through in a few days, the interrelationships among variables. And so it helps us with indicator design. But there are a lot of disadvantages, and the biggest one is that because people don't clearly understand the assumptions they are making, often they are not transparent. So they're not saying precisely why they are choosing this particular aggregation method, this particular approach. They simply run it in Stata. And they don't check their assumptions for robustness. And if you go into the literature, the book has some examples. How you add it up actually makes a big difference. And the examples show very divergent findings and conclusions depending which way you used an applied PCA or which way you applied factor analysis. Identification of who is poor is often difficult because you're identifying who is poor based on your vector of scores for each person, but you may not clearly understand what's underlying those scores. So usually, if they identify who's poor, they use some percentage of the median, for example. And comparisons across data sets are impossible because each time you redo a PCA on a new data set, then both the achievements change, but also the weights or the structure of the aggregation changes. And so you need to pool data across time in order to make and do a PCA across the pooled data to have strict comparisons. A disadvantage which is not mentioned here, but I think for us was very strong, is this use of this assumption that the data are cardinal. So what goes into a PCA if you are using a deprivation matrix? For example, if you are using a 0-1 matrix in which 1 means I'm deprived in child malnutrition, I'm deprived in fingernails, I'm deprived in adult literacy, deprived in housing, deprived in employment. It's a 0-1 variable. If factor analysis treats that as cardinal, then it treats each one as exactly the same. So it treats each variable as equally weighted. And so if you want to properly use some of these, you, for example, have to apply the weights so that each variable, the deprivation is its weighted value in order to execute the techniques. And the final thing is, it would be possible, and if one of you is very interested in axiomatics, it would be possible to bring out some axiomatic properties of these PCA and MCA-based indices. But to date, in the literature, that hasn't been done. And so that's a standing task that somebody needs to crack to try to figure out. But for example, they won't reflect focus. They probably won't reflect a number of the properties that I mentioned yesterday. And it's not clear yet to us which they do reflect. And so that's a bit of homework that we need to do as an academic community. Okay, now we move to fuzzy set approaches. Fuzzy set approaches are used a lot in technology. So I don't know if you have a dryer or if you use a dryer, but many dryers use a fuzzy set theory to decide if your clothes are dry and turn itself off. So this whole theory and this approach has many engineering applications, and it's very appealing for a number of reasons. So let me go through, there are many ways of applying fuzzy set approach. What I'm going to do is go through the clearest, which is its application to cutoffs. So in poverty measurement, we use a poverty line to identify who is poor. We use a deprivation cutoff to identify who is malnourished or who is illiterate. And those are very strict. You get a 0 or a 1 afterwards. But we may not be very sure, is $1.90 really better than $1.89? So this is the arbitrariness of poverty cutoffs. And is the person who has $1.93 really non-poor? And so the fuzzy set literature, as it's moved into economics, has drawn on Amartya Sen's approach. And particularly this insight that he had is that it's better to be vaguely right than precisely wrong. And it's tried to, in a sense, encapsulate that mathematically. And there's quite a large literature on that. A lot of it is in Italy. And so what they do is they often, instead of setting a poverty line, you would set an upper bound and a lower bound, let's say. Let's say we know that everybody whose income is $1 or less is poor. And we know that everybody's income who is $5 or more is non-poor. But in this band, we're not quite sure if they're poor or non-poor. So we are going to make a fuzzy functional form about the probability that they are poor. Now you can do it for the entire distribution, as in this graphic, where we have a poverty line, but we're going over the entire distribution. But it's more common to set an upper bound and lower bound, and then across a band of poverty lines to set a membership function. So the functional form that you apply is basically saying these people in this area where I'm not quite sure, we're going to give them differing probabilities of being poor according to their level of income, if we use the income example. So here's the band. We have a group certainly poor, certainly non-poor, and membership functions in the middle. So it can be bounded or unbounded depending on your preferences. I prefer bounded because I think Bill Gates, there's no probability that he's poor. So this is very appealing as an approach. It seems to go with I really object to the idea that 1 penny below or 1 penny above, 1 pence above or below, defines your poverty status. It's so clear that that's not the case when you go out and speak with poor people in communities. But one of the difficulties is selecting this membership function. So then how do you decide what probability people have of being poor? There are many ways of doing it. Do you presume it's linear, a linear function of their income? Is it trapezoidal? Is it exponential? Is it, what shape are you going to put for that form? There are many, many different options of membership functions. So usually what's done is that an author picks one. Again, what we recommend, and in the book we will show why, is we recommend if you use a membership function, you apply multiple membership functions. Because again, what actually happens is that your empirical conclusions change depending on the membership function that you choose. Okay? So what percentage of people are poor in society? That depends on your membership function. How poverty has changed over 2 periods, comparing them, that depends on your membership function. So then, playing that forward, you have fuzzy set poverty measures. You present the robustness in an academic and open, explicit manner. People know that it's just the assumption of membership functions that changes. And then the whole conversation in the press, the conversation in the government, is about which membership function to choose. But policymakers don't understand membership functions very well, and they understand poverty lines much better. And so at a very simple level, there's a sense that any poverty line is arbitrary, but trying to set it in a way that everybody understands what you're doing and then evaluate it over time with robustness for different poverty measures could be a more transparent way of capturing this insight from fuzzy set poverty that the poverty line, we should really test it for we should robustify it whenever we report it. So what is an advantage of the fuzzy set approach? It offers a measure, it offers a hierarchy, it does a complete ranking, it considers the joint distributions, it can be used with many different aggregation methods. All you're doing in this example is identifying who is poor, or the probability of being poor, and then you can do any aggregation method. So what you get, just to make sure that I'm clear, is that in a normal poverty measure, you'd have people who are non-poor being 0, and people who are poor being 1. And then you would add them up and get the percentage of people who are poor in the society. You could do FGT, 1, 2, Clark-Hemingway, Watts, any of the poverty measures. What happens in a fuzzy set approach is you have some people with 0, some people with 1, and some people with fractions, the probability of them being poor in this vector. And then you can make any poverty measure from that vector. And you can add it up and get a percentage of people, but you're not quite sure who they are, right? Because it's fuzzy identification. But you think that overall in your society, X% of people are poor. So I think the disadvantages, as I've mentioned, is that the justification of the membership function is really the hard point. And I say this as somebody who became enamored of fuzzy set approaches and decided I wanted to use them. And so put a good deal of time into using them and trying to justify them. And so I failed forward. And I can say I had a hard time justifying my membership functions. And also, in the empirical literature, often the robustness tests are not provided. And so again, you're hiding the assumptions that you're making, which is not a good way to do poverty measurements. There's also the issue that if you look in the literature, a number of the membership functions that are actually implemented in academic papers, at the moment this is rarely used in policy, they misuse ordinal data. So they take the mean, or they do a functional form which is not appropriate for ordinal data. And clearly, because of the assumptions you're making, you may find dominance or not find dominance, and fuzzy sets will tell you something different. So the last before the counting approach is axiomatics. So yesterday we went into the properties. We discussed why properties are important. We went through some properties like symmetry, replication invariance, scale invariance, normalization, and tried to give you an idea of the intuitions that they capture. And we presented, for example, the properties of the Foster-Greer-Thorbecke class of measures, and the fact that the head count ratio does not reflect monotonicity. The poverty gap does reflect monotonicity, but not transfer, and the squared poverty gap reflects all three. So the FGT class of poverty measures is but one in a huge sea of measures that have clearly specified the axioms or properties that they satisfy. And so we call this group of measures axiomatic. And what we mean by that is that they have made it so that we can read and simply find out which properties they satisfy and know with certainty how they're going to behave. And I contrast that with something like the DHS wealth index based on principal components analysis, where you actually don't know the properties that it satisfies. And so these are some of the many references, both in unidimensional and multidimensional poverty measurement, of axiomatic measures whose properties are clearly specified. Some of the key papers that are extended in multidimensional space are the Foster-Greer-Thorbecke that we went through yesterday, a Watts paper, and a paper by Satya Chakravarti based in India. So if we think of the multidimensional poverty literature, in the late 1990s, the first paper that we know of is a chapter in a book by Satya Chakravarti, Mukherjee, and Ranade, published in India in 1998. It's a fantastic paper, and it names, for example, factor decomposability. It has an interest in policy in subgroup decomposability, and it's, for being the first paper published in a subject, it was remarkably insightful. Around that time, 1998-99, the drafts of later papers published in 2003 emerged. So Tony Atkinson's paper and François Bourguignon and Satya Chakravarti's paper were both published in 2003, but written at that same time. And those two papers really started this field of multidimensional poverty measurement. François Bourguignon and Chakravarti extended the Foster-Greer-Thorbecke class of measures, and they also made some important points. For example, recommending that a multidimensional poverty measure should have a deprivation cutoff for each dimension, and not aggregate, so to have a row first approach, but set deprivation cutoffs for each dimension so that each entered with intrinsic value. They used the capability approach to underlie their work. Tony Atkinson's paper in 2003, I'll return to shortly, but it advocated that this axiomatic social welfare tradition come together with the European tradition of counting measures. And many of these other papers proposed different measures with different properties. One of the features of all of the measures until ours in 2007 was that all of them required cardinal data. So the Bourguignon-Chakravarti paper, all of the measures that they presented require cardinal data. So the empirical implementations are a little bit limited because there are not that many variables you can use them with. So we are a member of this axiomatic approach, and the multidimensional traditions that began in 2003 all look at the joint distribution of deprivations, all create summary measures, all specify the properties that they satisfy, and so provide a clear understanding of how the measures behave and what they respect. And that's the clear advantage of this whole literature. Clearly, no measure can satisfy all desirable properties, and some measures that satisfy many properties at the same time are hard to explain to policymakers or to your grandmother. They're too complicated. We implemented all of them. We didn't publish it, but we implemented everything that had been proposed initially when we were writing our first paper on the topic, and it was remarkably difficult to really try to explain what this 0.372 or whatever actually meant in practice. And so there's a lot more work in some of these measures of interpreting them. But really, this is a literature which continues to extend and to expand, and which we very much are part of. And we are hoping that many more measures that can use ordinal data will be developed in the years to come. So the very last, and then we have coffee, is the counting approaches. And this is chapter 4 of the book. And counting approach is a generic term, and it refers to a particular method for identifying who is poor. And you either count the number, if the dimensions are equally weighted, or you create a weighted sum of the deprivations that poor people experience. And when Sen, in 1981, in Poverty and Famines, was talking about poverty measurement, he said that there are indirect ways to measure poverty, and he thought that monetary measures were indirect, and that there were direct measures to measure poverty, like, is somebody malnourished? Does somebody lack a decent house? And so the counting approach, with the cutoff for each dimension and looking across the different overlapping dimensions people have, reflects this direct method. And it's been widely used in policy since the 1970s. And here we have an interesting feature. We are trained in economics and statistics and sociology and social research. And what we found is that very often people with our training are not aware of the counting methods. And this is, in a sense, the signal contribution of Sir Tony Atkinson's paper. It was to say, hey, you economists, look at this literature. It's relevant for policy. It can be rigorous. Look at the techniques that are actually being used. So in terms of identification, you identify the dimensions that will be columns in your matrix. You assign weights to them. You define who is deprived and who is non-deprived in each indicator. And then you apply those deprivation cutoffs to see each person if they're deprived in that indicator or not, giving them a 0 if they're non-deprived and a 1 if they are. And then you produce some sort of weighted deprivation score. And you identify people as poor if their weighted deprivation score exceeds or meets some particular threshold. So the counting approach is used by the AF methodology. It's used also by many other empirical work. So for example, already back in 1974, Lenoir spoke about social exclusion in Europe. And he was using counting-based approaches, identifying people as socially excluded if they lacked X or more achievements. In the same year in Latin America, the Cocoyoc Declaration ushered in an era of measuring unmet basic needs. And after the Cocoyoc Declaration, beginning in Chile and then traveling through much of Latin America, unmet basic needs measures were implemented, often using census data, simply counting who is deprived in 1 or more, 2 or more, 3 or more of a list of fixed deprivations. In Latin America, the list was quite fixed. In Europe, the list was quite flexible. So there are differences between the different regions. And it's also been applied in other places. We found that Julio Boltvinnik from Mexico flew to Iran in the 1970s, and that the Arab region had a number of basic needs measures from that period. Also, it has, in a sense, been generated independently by different NGOs. I worked with Kodumbashri in Kerala, and they had, just to make something simple, a woman was destitute if she fulfilled 3 out of 9 criteria, for example. The Targeting the Ultra-Poor Poverty program in BRAC in Bangladesh similarly uses a counting-based measure. They're easy to understand. So there's no high theory behind this. It's a very intuitive approach. NGOs, others use it. And so you don't have to find one academic source document. But this general approach is one that, as we will see, can be applied very rigorously using ordinal data. So I'd like to just mention a few of the interesting applications. Peter Townsend in the UK was a very important figure in the 1960s and 70s, 80s in poverty measurement. And he established this research center which continues to this day in Bristol, which looks at poverty in the UK. And he began with a survey listing 60 indicators in 12 dimensions that might be related to UK poverty, and then boiled it down to 12 items, equally weighted, and said that people who experienced at least 5 of these deprivations were probably deprived. Now, he used this measure to cross-check a relative income poverty measure that he was working on at the time. So it wasn't initially used by Townsend as a standalone counting measure. But it inspired a lot of work, including bringing out already in the 1970s this mismatch between economic deprivations and income that we saw yesterday. In the 1980s, there was a woman called Margaret Thatcher who said that there was no poverty in Britain. And so Mack, who was a journalist, Joanna Mack, and Lansley decided to test her assumption. And they created a Breadline Britain survey. And they asked people which items they considered necessary for British people at the time. And there were 26 items that more than half of their survey respondents considered necessary for a decent life. And then they asked people if they lacked this item, if they lacked it because they didn't want it or because they could not obtain it. And if people lacked something and could not obtain it, then 3 or more of these items, then they were identified as poor. So Mack and Lansley, 1985, clearly did a counting-based measure. Clearly it was trying to reflect the social norms in Britain of the time because it was very important for their legitimacy to do so. And it also had to be quite simple, as one of the 2 co-authors was a journalist. But it had quite a big impact and certainly jump-started many subsequent studies. And so you'll have the slides. I won't go through each of these, but they're quite similar. So Callan, Nolan, and Wieland, in a broader study beyond Britain, also did a counting-based approach. The EU 2020 poverty measure we've already seen. So on this slide, I describe each of those 3 balls that you've seen as depicting in the Venn diagram, depicting the 3 different indicators that are components of the EU 2020 measure. And so these are slides from the Eurostat website showing the 3 indicators separately and then the importance of looking at their overlaps and considering their overlaps. And as I mentioned, this is done for every country individually, and the extent of overlap varies really quite a bit by countries. And there are many, many more implementations, particularly in Europe. This has been used very widely for social policy in Europe. Parallel to this European work, as I mentioned in Latin America, the first unsatisfied basic needs measure was implemented in Chile, and they used 5 census indicators: overcrowding in terms of housing, poor housing quality, poor sanitation, children not attending primary school, a household head with 2 or fewer years of schooling, and a high number of children and elders per workers in the household. And they would report what percentage of people in the society suffered at least one of these 5 deprivations, what percentage suffered 2 or more, and what percentage suffered 3 or more. And they used these because they were from census data to create poverty maps. This was before the Lanyau poverty mapping using the regression coefficients of income poverty. And the similar methods were extended to many of the Latin American countries using initially these 5 census indicators to create unmet basic needs maps. And then other methodologies have built over them. And as I mentioned in the Arab region, some of the living conditions literature draws on the basic needs literature from Latin America, but it uses different indicators in constructing appropriate living conditions rather than poverty maps in those countries. And I think the final one that I wanted to mention is that there are a number of child poverty measures that use counting-based approaches. So for example, in the same Bristol Center where Peter Townsend was, Dave Gordon and others created a child poverty measure using a counting-based approach in 2001 and 3, and then that was published by UNICEF in 2004. And they used indicators and cutoffs reflecting the Convention on the Rights of a Child. And then, of course, there are AF implementations that we will discuss later. So what are the advantages of the counting-based measures? First of all, it's very simple. So NGOs use it, non-experts can understand it. If you are trying to figure out if you are eligible, you can look at a list of 9 things and see if you suffer 3 of them or no more. It has a kind of intuitive appeal. It looks across the different deprivations, so it reflects joint distribution, and it allows both cardinal and ordinal variables. And the reason is that it dichotomizes, it cuts all of these variables into simple 0 or 1. Are you deprived or not? And that step of dichotomizing, of making ordinal or cardinal data binary, having only a 0 or a 1, a deprivation or a non-deprivation, that means that the resulting measure based on this dichotomous data are robust to monotonic transformations of the underlying data and the cutoffs. And that is what's required mathematically for a poverty measure built on ordinal data. The disadvantage, of course, is that a counting measure is only as good as the indicators it includes. That's why we'll spend tomorrow trying to think about what indicators to include. It also requires weights to add up to an overall aggregate. I don't think that's a disadvantage. I'm not sure why we put it there, but it is a feature. It does dichotomize. It makes this radical step of cutting the data into people deprived or non-deprived in each dimension, and you lose some information. We will talk about workarounds for that, for example, using a different deprivation of cutoff for destitution and poverty, or for poverty and middle class or moderate poverty. And sometimes counting approaches in the literature have been combined with methods that are not appropriate for ordinal data.